In this video, we're going to review the gas law constant lab that we did in honors chemistry. It's a classic lab, and there are a lot of components that will help you on an AP test and on this worksheet with gases. So let's take a look at this. So we're trying to solve for the gas law constant, which is R. And really, the way to do this would be testing a lot of different gases under a lot of different conditions. We're going to test one gas under one condition, so I don't think we're going to prove anything, but at least we can verify that getting this R makes sense if we can get pretty accurate results, especially class-wide. So I'm going to just scroll through this. Notice this vapor pressure chart for water. We're going to come back to this, but I think our temperature is going to be 22 degrees, and the vapor pressure of water at 20 degrees is about 20 millimeters mercury, or 19.8 millimeters mercury. We're going to end up using that piece at some point. Okay, I'm going to skip through the pre-lab, and there's a procedure, and I would take a real close look at this and try to follow along with that. I'm going to give you a little synopsis of that right here. So looking at this, I have a gas collecting tube right here, and let's see, this gas collecting tube looks like a big barrette, but it actually has a rounded edge, and it actually has etches, and it would be a 50. I think this is actually a 100 milliliter gas collecting tube that we used. Okay, and then what happens is we have water here, and then in this tube, I filled it up with 10 milliliters of like 6 molar really strong hydrochloric acid, which would react with the magnesium, and then the rest with water. So then I topped it off up to here with water. And then I flipped it over and inverted in here. So at this point, it's going to be all liquid right here, okay, at the point of inversion. There's a piece of magnesium. It's just stuck on a copper wire, so it doesn't float up to the top right away. And there's a rubber stopper with a little hole going on right there. So that's a little bit with the setup that we have going on here. Well, the hydrochloric acid is going to be more dense than the water. So it's going to sink down to the bottom. And when it meets the magnesium, we're going to get this reaction, magnesium plus hydrochloric acid, and we're going to get hydrogen gas. And the hydrogen gas is going to start bubble up. Blah, 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 blah. It's going to bubble up in there. And hopefully it stops bubbling before we get to the end of the tube right here. And then we can take a measurement of what we have. So I usually let the temperature settle, knock out any air bubbles, and then I can actually read the volume of this airspace in here with the gas collecting tube, sometimes called a eudiometer, and is what we call it. So that is where I'm getting my data. So I'm going to, meanwhile, take the pressure in the room, the temperature in the room. We're going to assume the temperature in the room is going to be the same as here because I'm going to let it equalize for a few minutes after the reaction. And then I got the volume of the gas right here. So those are going to be some of the data points that I have in solving this right here. Okay, so let's go down and take a look at our data for this and see where it goes. There's a little pre-lab question, but I weighed out my magnesium and I used a fancy balance and I found it was 0.0400. So using a real fancy 10,000th of a gram balance right here. I have 3 sig figs. I convert that to moles and I get my moles of magnesium used. Okay, I just read a barometer, which gives me barometric pressure, normal pressure in at 1 atmosphere, and sea level is 760 millimeters mercury. Might be a cloudy, a little bit low pressure day. Okay, so we might have got that right here. Room temperature is 22 degrees Celsius. I'm going to convert that to Kelvin, because when you use PV equals nRT, you will always use Kelvin. Notice 2 sig figs here, but when I add 273, it does become 3 sig figs. So that's an important thing to note with that. Okay, this is from that table I showed you earlier. I got 19.8 millimeters mercury is what I got from the normal vapor pressure of water there. And then what I'll do is the experiment's equilibrated to normal atmospheric pressure. Okay, so that's going to be the total pressure. And I'm going to say that's the pressure of the hydrogen and the water vapor. So what happens is you collected hydrogen gas, but a little bit of water does actually escape out of that tube. So a little bit will be vaporizing. And the higher the temperature, the more it'll vaporize. So that a little bit of water gets in there and it becomes a little bit moist with water. So you don't have strictly hydrogen, you have a little bit of water vapor. Now, the higher the temperature, the bigger effect that has. but you should be in the practice of subtracting that out. And you'll see that in a couple of problems that will do that. Notice here, it's not a huge difference percentage-wise, but if it's a higher temperature, it could be a bigger adjustment. Okay, I have 40 milliliters. That was what my volume reading was. And then notice the moles of magnesium and the moles of hydrogen are in a 1-to-1 ratio. So I'm assuming that moles of magnesium got completely converted to moles of hydrogen. Because magnesium was the limiting reactant, it all got used up. And we're assuming that all goes to hydrogen. Okay, I think I got enough data to solve this. Let's take a look at what we got. So I'm going to use this 725. I'm going to use that adjusted, just the pressure of the H2. I'm going to use the volume that I saw. I'm going to use the moles of magnesium, which is also the moles of hydrogen. And I'm going to use my Kelvin temperature. I'm going to solve for R. Notice the units on this, and I end up with 59.6. I think the accepted value is 62.4. So it looks like about a 5% error there. And we go through right there. So just a little review of a lab we've done, but you got this thing with partial pressures, and kind of showing how we could determine R, and take a closer look at the procedure and the calculations to make sure that that makes sense to you. And you get a little practice of that with that or concepts from that in your homework packet. Thank you.